Good afternoon, and welcome to today's electronic design webinar titled Mitigating Supply Chain Risks, Onshore Assembly Solutions for Long Life Cycle Systems, sponsored by Rochester Electronics. I'm James Mora, Senior Editor at Electronic Design, part of Endeavor Business Media. To start, let me explain how you can participate in today's presentation. First off, if you have any technical difficulties during today's session, please type your issue into the questions window, and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. We also welcome your questions during today's event. We will answer as many as possible during the Q&A session following the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on Electronic Design within the next 24 hours. You'll be notified by email when the archive is available. Now, it's time to introduce our speakers for today's discussion. Daniel Dice is the Vice President of Design Technology, and Edward Fontanilla is the Director of Assembly Engineering for Rochester Electronics. Welcome, Daniel, and Edward, please go ahead.
Thank you, James. I appreciate that, especially the introduction where we ask the audience for questions. So we really do want an interactive session as much as possible on a webinar here. And we encourage you to please type in your questions, especially as you see them, as you see the material. We want to address as many of those as we possibly can, or at least follow up with you later. So today's webinar is really onshore assembly solutions for long life cycle systems. What does that mean? What are long life cycle systems? Pictures down below there is a train, that's transportation. Of course, automotive is a long life cycle system. Nobody wants a car to not be able to get parts 10 years in when the average life of a car is 12 years. Commercial avionics is another place. Airbus, Boeing, and everybody that makes anything for them. They don't want to change once something is qualified and in place. Medical, industrial controls, all of these have long life cycle systems where change is actually expensive and goes against proven system operation that's been in place for a decade prior or 2 decades prior. That's the customers we're talking about here, and that's how onshore assembly solutions can mitigate some of those supply chain risks. So let's go into this. Again, thank you for joining us and appreciate your time. Everyone has, that's one thing nobody has infinite amount of, and we really appreciate spending some of that with us. So I want to go through today what the offshore supply chain risks and challenges are, what happens there, what is going on, manufacturing initiatives we're putting in place to mitigate obsolescence, and then Rochester's licensed manufacturing capabilities. You know, I recently had an opportunity to talk to a customer of ours that their lifetime of their system is actually 60 years, not 10, not 15, not 20, but 60. And you can imagine, and greater, the challenges they have. And so you can't really address that in a normal way in today's semiconductor market. So I think what we're putting in place here does address a lot of that. All right. So what's in place today? What's going on today in the market? More components becoming obsolete at a faster pace. We just went through a period of time where there were supply chain shortages. People couldn't get enough parts. Classic, what happens is overbuying and kept going at a rate that they couldn't. They put in place purchasing too much. Now they're sitting with stock that's too heavy. They really don't want to buy any more parts. The semiconductor companies are looking at this as an opportunity to consolidate product lines. During a boom, everything is selling from a semiconductor market perspective. During a downturn, inventories accumulate, you're not moving product, it's an opportunity to refocus. And what triggers then is you get all these obsolescence notices. People cut product lines. They're trying to make sure that going forward that they only focus on those that are making the money. The major OSATs, the offshore assembly and test companies, are moving away from lead frame assemblies, especially those that require trim and form tooling. So your dips, your PLCCs, your plastic quads, eventually all of these are going away. And it's only a question of when, not if, they're going there. And PLCCs is a great example of they're gone from the two largest assembly houses at the end of this year. So suppliers are consolidating product lines. You're looking at the booming market that left us, and now we're doing heightened product line focus. Still seemingly endless supply chain challenges. Managing an OSAT supply chain, that's not really manufacturing at all. That's just, you're trying to mitigate some of the risk of a long-term product, but in reality, whoever supplies the assembly, whoever supplies the test, whoever supplies the package could have an obsolescence reason. A lot of times obsolescence is really brought on by silicon obsolescence, package obsolescence, tester platform obsolescence, and lastly, revenue targets that aren't met. Those are really the big four from, and why does obsolescence happen? And this webinar is really focused on the assembly manufacturing side of things and the test side of things. We think that, sure, there's always silicon obsolescence, and that grabs the highlights a little bit, but in reality, you got four things driving obsolescence. The latest CHIP Act investments are not most of the long life products. They're leading edge. They're leading edge technology investments. Just saw $8.5 billion investment with Intel. That's not stable analog, let's say, technology nodes at all. That's all leading edge. And you can see the investment, $1.5 billion in global foundries. That is all leading edge. It's to bring leading edge more to the U.S., but it's not long life products, and that's another reason why we're making the investments we're making. Last bullet here is that one of the challenges is a lot of the semiconductor companies, more of the semiconductor companies over time, are fabless. That means they're not controlling semiconductor fab process obsolescence unless they happen to be driving the volume in any given node. They lose control of that. They deem the control then to whoever's driving volume in that node. And that volume is typically not long-term system volume. So again, as more companies become fabless, and I think right now 5 out of the top 10 in revenue are fabless, they don't control the fab processes on which they're on. Many of them are TSMC, but there are other fabless companies out there as well that don't go to TSMC, but again, they don't control their own destiny from a fab process perspective. So options for extending supply, we've gone through this before on previous webinars, and I do ask that you take a look at the reference material along with this webinar. We've posted a bunch of things that we've written before, all on this whole topic of long-term availability, whether that is silicon, whether that is packaging, whatever. We've got that material posted out there for you that you can download from this webinar. So options, common options are last time buy, in-house long-term storage. Sure, that'll get you there, but how good are you at predicting how long your system has to live? Purchase of long-term components from an authorized distributor, absolutely, you can do that. You need to make sure that the parts are authentic and authorized. everything from Rochester as an example is 100% authorized. We don't go take parts back that have left the authorized channel. Even if they're in an unopened box, we don't hand wave our way around all that stuff and mix stock. Everything we have is 100% authorized. Not everyone does it that way. A lot of people will kind of hand wave their way through. Well, yeah, it left the authorized channel, but it never got open, so it's okay. Or, well, I'm going to purchase excess from people that bought too much. That has left the authorized channel. That is not AS 6496 compliant. And there is a risk at that point that you're mixing used parts with new parts and so forth, and who's going to know the difference? That's not what we do here. And then the last thing is work with a licensed manufacturer, one who's really investing in their own manufacturing and is authorized to continue component supply, and we're here to help. Last slide, and then I'll turn it over to my colleague, Edward, who will give you all kinds of good information on assembly and test and where we're going. But really just a little history of Rochester's investment is we've been driven by our customers and the semiconductor companies directly to invest in certain ways over time. Our latest investment is all the plastic packaging, hermetic. We've been in that for a while, and really it's driven by our customers. So the Q&A that we're asking you to participate in here, that helps drive us as to what we go do and what you want us to go do. There's a history of investment here in US-based manufacturing and design. 2008, I got to start the design team at Rochester and going strong ever since. And we've been making this sequence of our own test, our own assembly, our own design, so that we can truly extend the life of a semiconductor product. So with that, I want to turn it over to my colleague, Edward, and let him fill you in on a lot of details.
Thank you, Dan. Good morning, everyone, and thank you for taking time out of your busy day to attend our webinar. I'm Edward Fontanilla, Director of Assembly Engineering. I will be taking time to discuss today on how Rochester Electronics mitigate the risk, as previously mentioned by Dan, regarding the onshore supply chain management for legacy products. In this webinar, we will be sharing to you the following sustainable actions or mitigation plans to prevent a line down crisis from end-of-line semiconductor components or obsolescence. Topic 1 is more on the expanding domestic manufacturing capabilities. As we explore that the semiconductor landscape in the upcoming year presents a mixture of acute difficulties and exciting opportunities. The market somewhat unpredictable due to the factors like production output uncertainty and geopolitical tensions alongside continued demand fluctuations. With the growing instability of overseas semiconductor supply chains, the domestic manufacturing solutions provide a secure production strategies customized to meet customers' unique requirements and ensuring stability and reliability. Item 2, I will be talking about enabling assembly solutions for legacy products. When we talk of legacy products, these are the long life cycle solutions which have a long life service like 10 years and above. These are the markets such as automotive, industrial, medical, aerospace, and or defense. A while ago, Dan talked about the risk and challenges about the major OSATs moving away from the lead frame assembly, such as DIPs, PLCC, or the power quad QFPs. Secondly, many devices become obsolete when they are no longer manufactured by original manufacturer, or what we call the OCM. On my succeeding slides, I will share to you how Rochester enable and support solutions for the legacy product. And lastly, but third, is more on growing key manufacturing services for specific for assembly test and quality. One of the risks that we found out are the mature technologies continue to drive volatility for long life cycle systems. In this informative webinar, we will discuss to you the state of the market, the manufacturing technical capabilities, and how Rochester invests the infrastructure for customizable source of onshore assembly testing to mitigate the supply chain risk. In a nutshell, if you look at the graph, Rochester invests primarily where the OSAT discontinue the product or the original component manufacturer stop investing. Topic 1, let us talk about expanding domestic manufacturing footprint. I will talk more about how Rochester support customers to prevent the risk and the challenges about the major OSATs or OCM moving away from the lead frame assembly. As a good example, if you heard the news about our top OSAT partners like Advanced Semiconductor Engineering or ASE and Amcor Technology announcing the end of life or product discontinuation notice in 2023 about the product PLCC or the plastic lead chip carrier. Second risks we wanted to share with you are the suppliers consolidating product lines, impacting the decreased production pace and increased end of life. Again, a good example, we have OCM in Asia, where they are consolidating their product line just to save cost and gain productivity, and started to end of life one of the legacy product, which is known the PBGA or the plastic ball grid array. To mitigate the risk, Rochester Electronics Solutions is investing to expand the infrastructure to support. One is the domestic manufacturing, and then we have the capabilities, the people and resources, plus manufacturing services that will sustain the entire long life cycle solutions and backup capacity to prevent supply chain disruptions. You can see in the slide, Rochester Electronic in Newburyport. We have 3 manufacturing sites, which we are expanding the manufacturing footprint in one of the latest plant we have and double the capacity of the current productions, like the Building 9 in Newburyport. Topic 2 is all about enabling package assembly solutions. This is the second mitigation plan by Rochester to address the risks and challenges on about more components are becoming obsolete at a faster pace. Increasing the numbers of components discontinuations are significant threat to our military, industrial, and aerospace and defense markets, as they have some of the longest productions and service lives. As we all know, the semiconductor industry is evolving regarding manufacturing technology and consolidations. The risk, as mentioned earlier, is that suppliers are consolidating the product lines, affecting the decrease in production pace and increasing end of life. This typically means all components reach end life sooner, and more applications and industry segments are affected by obsolescence. Rochester Electronics Solutions is to enable the package assembly for legacy. You can see in the slide more products being developed and qualify in 2023 to 2024 onwards. Expanding the product family, both for plastic and hermetic packaging, and qualifying those end of life by OSAT or OCM. Some good examples, as me and Dan mentioned earlier, are the PLCC packages. And in addition to that, we explore as well that the QFP, the SOIC, the TSSOP are soon to be end of life. And Rochester is stepping ahead and mitigating this problem as early as possible. Going to the assembly package process solutions, Rochester Electronics advances the assembly to mitigate the risk. Why OSATs are moving away from lead frame based is that because the fact that these products require more of expensive tooling such as trimming, forming, and singulations, or sometimes the requirement involves different lead finishing from thin lead to lead-free options. In this slide, Rochester Electronics enabled technology solutions mainly on three divisions, what we call the pre-assembly, the front of line, and the end of line divisions. Enabling solutions such as in pre-assembly, we have dedicated the line in one of our new building, as I mentioned earlier. This is to support the automated batch processing for our 300 wafers and to have the capability to trim down to thinning down to 50 microns capability on the wafer thickness. As we all know, customers are migrating to a thinner packaging options. Thus, they need a thinner wafer. Just to give you an example of a market on a memory solution for automotive and aerospace, they require a multi-chips or stack die options, which require about less than 100 microns wafer thickness. For the front of line, we are expanding the manufacturing footprint to support additional machines like die bonders and wire bonders, which will support the double capacity for our legacy market or products such as military, the automotive, as well as not only for legacy, but also to step ahead and develop those new advanced product like flip chip or power product line. In case of end of line, this is the area where Rochester Electronics invested a lot of new systems from 2023 up to date. Just recently, we have qualified the new electroplating line that will support lead finishing services on thin lead to lead-free options. We are also expanding the legacy product line, such as PDIP, PLCC, and QFP, plus those new advanced products, which are the BGA and QFN. Later on my succeeding slides, I will take time to capture why we are moving towards the QFN product. And lastly, we are also qualifying the package inspection systems, which will enable the military and automotive process control requirement in the next couple of months. In addition to assembly challenges discussed for supply chain, Rochester Electronics explored the capability to continue to perform electrical testing in some of these products can be also at risk. Test system obsolescence is a dynamic along with silicon package and obsolescence. To counter this risk, Rochester has taken the approach of sustaining test capability on many legacy test platforms to ensure test capability and capacity as the subcon test landscape continues to evolve. This extends not only for the test systems, but also to the handlers for many of these packages. Looking into the slides, Rochester is enabling the test market for digital, mixed signal, the analog power discrete or the standard logic, memory, wafer sort, and burn-in. Taking the leap to support on advanced testing, like in 2024 onwards, we are developing and qualifying those leading tech system. Just to give you an example, J93K, T2000, Catalyst, or Uplex. This is to support both digital mixed signal and standard logic. The other system that we have is the ETS88. This is for the analog and power discrete. And as we all know, memory will be ramping up in a few years. We are also supporting to develop a Magnum test systems. And in fact, not only to the test system, but also to the wafer sort, which we will be using instead of dual temp. We will be using tri-temp already. And the dynamic switching with high voltage for burn-in, with high volume and complex devices memory. The third sustainable actions that we need to, not only the package or process solutions, but of course, we are growing the additional manufacturing services to support our customers' demand to prevent any disruption and obsolescence of end-of-life components. Rochester is engaging in full range of manufacturing services, providing single solutions through a full turnkey manufacturing solutions to enable faster time to market. In this slide, the focus areas such as wafer and die processing includes wafer storage or die banking, dicing, die inspection, and sorting using state-of-the-art equipment in our new Berryford facilities. Again, wafer storage, as we all know, if you don't have long-term storage, it is a represents of a viable solutions in maintaining a continuous supply of semiconductor components in a long life cycle applications, where the next generation storage that we enable are the example real-time automated environmental and process controls. And this will support long life cycle solutions required by our market segments like military, industrial, and medical customers. The next is component lead finishing. We enable the solutions like thin lead solder dip for hermetics or flexible rack plating systems and new electroplating systems that will support plating options of lead frames and the other electronic components configurable for other plating options such as conversion of RoHS to thin lead or thin lead to matte thin plating. And for the test services, we enable a range of high quality test services, just I mentioned earlier. This includes for analog, digital, mixed signal, memory, and power. It with a range of legacy platforms through to advanced test solutions. As we grow the solutions by adding automated tri-temp probers and handlers, this will also support some of our customer requirements specific to those automotive and military. And lastly, the analytical services. We have significant expertise in which enable our customers to accelerate failure mechanism, help identify root cause, and take actions to prevent failure mode. You can see in the slides, we have been certified also by Defense Logistic Agency, which is a key for aerospace and defense market, as well as enabling analytical service for military standard, including space, which are group A, B, C, D. The range of analytical services, in summary, includes our electrical, materials, and polymer analysis, including those services for automotive markets such as thirst burn-in, temp cycling, HAS, thermal shock, or gross leak testing. These are the manufacturing services that we mainly offer to our partners in semiconductors. In addition to these manufacturing services, we explore the risk of legacy product quality and reliability, and market industry is going for automated process. Rochester Electronics enables some of the new and latest manufacturing services to follow the best known practices in the industry. As you can see in the slide, example is the automatic package inspections. These are mostly required by the automotive or military market segments. We developed and qualified copper bonding. As we all know, some of the automotive, military, or memory solutions are moving towards gold to copper or silver to copper bonding. The other thing is we have enabled and qualified the BGA QFN auto molding system. Since this BGA and QFN are more specific to a matrix lead frame or high density lead frame substrate that needing some automatic molding system process, you cannot just make use of the manual or semi-auto manual mold system because of the um, handling issues when it comes to a high density lead frame or substrate. Again, we have also developed and qualified the integrated solder ball mount system for our BGA and soon for our flip chip line. And lastly, since we are embarking to the advanced packaging right now, which is BGA and QFN, we have also developed and qualified our package automatic saw singulation system. Later, I will talk about QFN on my succeeding slides before I give the floor to Dan again. And this is to ensure long-term component support for our existing SOIC footprints and small pin counts, PLCC, and QFPs. In part one of our exploration, we reviewed the history and risk of how and why semiconductor assemblies have moved away from classic lead frame assembly. For a recap, these require expensive trim and form tooling, such as those PD, PLCC, or QFP. And the market has moved toward QFN or DFN type kind of assemblies. In here, we direct our focus on QFN and DFN assemblies, which are on the lower end complexity and cost, which will have high impact on the future of SOIC or low pin count PLCC and QFP assemblies. In Rochester, we believe that offering the flexibility to keep existing SOIC package, PLCC package, or QFP, the board mount or the board layouts for signal while providing a QFN assembly is the best path forward to support long life cycle systems. Looking into the slides as to why DFN and QFN make sense going forward. Number one, QFN assemblies are lead frame based. They do not need trim and form tooling. I repeat, QFN assemblies are lead frame based. They do not need trim and form tooling. Second one, the lead frame for a QFN is an X and Y matrix where the X and Y dimension are individual QFNs are flexible. And the third, the mold tooling dimensions and outside lead frame dimensions are the same of many QFN final assembly dimensions. It's unlike the PLCC, you have different lead count, you have different strip sizes. If you look at the slide, you can see common dimensions of individual QFN assemblies such as 3x3, 4x4, or up to 8x8, and many other sizes. Number 4, QFN and DFN are molded at once and then sewn to form the individual QFN assemblies. The dimension for DFN or dual flat no leads assemblies are more varied but always at the smallest of pin count as compared to QFN. If you look at the slides, you can see an 8-lead SOIC or 8-lead MSOP or 10 leads SOIC can be converted to an 8-lead or 10-lead DFN. Today, Rochester Electronics offer customers many QFN compatibility with SOIC also and small pin count PLCC. This can be easily accomplished with a simple board modification for the paddle area under the QFN. The modification to the board is required for SOIC or PLCC equivalency in shock and vibration environments. Another good example here is, you can see in the slide, we have converted 28 lead PLCC to 28 QFN. One of our customers in Asia obsoleted because the product and the process really are too old for PLCC. It's about 3 to 4 decades in the history. So mainly the parts and services are no longer existing in the market. So Rochester was being successful in converting this product to QFN. And we explore also that some of the QFPs are migrating to QFN. If you look at this slide, you can see LQ, TQ, or MQ type of QFP are moving also to QFN. This is to mitigate the risk, and we set up an equivalent QFN derivative solutions, which can work also to a 10 by 10 QFP, like the dimension of 12.6 by 12.6 QFN. With that, I give back the floor to Dan and continue on the next slide. Dan?
Thank you, Edward. That was a lot of data, folks, and I want to take a moment to go back just a little bit on one of the slides and talk a little bit about tester platform preservation as part of obsolescence. And Edward touched on this, but I want to give you a real example. Why would somebody do this? Why wouldn't you just want the latest tester platforms and just have everything supported and working with the latest from whoever you're working with? Real simple reason for that is, when a semiconductor company develops a product, especially a complex processor type product, they will spend many man years putting together a test solution that is tied to the tester platform. A regular test house, if you take a look at what a regular test house does, they're presented a challenge of, here's the data sheet, go test the product. They're not given or trusted with the real test program that comes from the manufacturer. So that's not what Rochester is doing. We're actually getting the real test program from the manufacturer that caught every possible escape that ever came out from that product when it was running in volume. So for that complex of a test solution, you're really better off trying to stay with what the original platform was. I'll give you a couple of live examples, 3 of them actually. Motorola processors back in the day, the 68020, 68030, and 68040 processors, those were all developed on the J971 test platform. We maintain the J971 test platform because that product is still viable with Rochester. We've actually ported the product, the 68020, the 68030, to another foundry, and we keep manufacturing that today. So it makes sense that we keep the same test platform. So the diversity in platforms that we've got here with handlers as well as test platforms, we're not simply doing data sheet testing. We're not just cranking out a test program based on whatever the data sheet says. We're actually dealing with the real IP that came from the manufacturer, so that we can keep testing the product exactly the way they did when they had it active at the original manufacturer. So that's one thing I wanted to emphasize a little bit for you. And the last slide here that Edward talked about, we want to be able to preserve the board layouts for the customers. I think this is a really important point that Edward brought forward. Mitigating obsolescence is also making sure that, above all, our customers are not having to redo anything. Of course, the biggest expense of all is software. Customers don't want to touch software. That's an order of magnitude more expensive to change than hardware. But in this case, they've also spent a lot of time and effort, a long time ago probably, doing signal integrity analysis at the board level. And what Edward said is absolutely true, and that is we're not just offering a QFN that's 3x3 or 4x4 or 5x5. We're also offering QFNs that can replace lead frame packages that need trim and form tooling, and for the customer to keep their board layout as much as possible. So by investing in doing our own assembly and our own manufacturing, we're helping retain customer systems for the long term. We're not just hoping the OSATs continue doing something that they're doing. So let's again talk about conclusions here, and then I'll turn it back to James for Q&A. We're continuing to do this domestic investment in manufacturing to extend the life of semiconductors. This means everything from going out and hiring people from remote locations that we're doing assembly operations and bringing them to Newburyport, Massachusetts, where our headquarters is. So we're actually going so far as to hire people out of locations that we're doing that. We kind of had to do that for assembly. Everything we do is driven by customers and semiconductor companies. Again, please ask questions, participate in that Q&A. And we're always improving and trying to increase our capabilities, but we need feedback as to where you want us to go. And we've got everything from design, wafer processing, assembly, test, REL, and analytical services all under our roof. I get to manage the design team at Rochester. We didn't talk about that on this webinar, but we actually port product from one fab to another when we're given the database to do so, or the database is extremely old and nobody has anything on it anymore. Sometimes we can also clone that product, and we're doing that actively today for a lot of the commercial avionics customers. Domestic assembly at Rochester enabled by licensed manufacturing and a facilities investment. We're in partnership with OSATs, but we're not limited only by their offer. So providing a continuous source of supply, we're trying to extend the life of legacy packages. As Edward mentioned, PLCC is going away 2023. ASE already left. We're trying to pick right up and let customers continue to have those same assemblies where it's practical to do so. We have long life product storage. We've got BOM Insight programs, again, all meant to enable customers to continue shipping the same systems. You just got to bring us in to have that discussion. So key manufacturing services, Edward went through all this. Custom plastic assemblies where appropriate. So again, please reach out to us. I think we can probably help keep your system going. And with that, I'll turn it back to James for any Q&A. Thank you.
All right, thanks, Daniel. A few of you have already submitted questions, so we're going to jump right in. As a reminder, if you would like to submit a question, type it into the question window on the side of your screen and hit the submit button. All right, so the first question we have here asks, why are DFN/QFNs the only products you're recommending switching from SOIC, PLCCs, or QFPs?
Edward, why don't you go ahead and take that one?
Yeah, Don, thank you. Okay. Great question. Previously, we explored why classic lead frames technologies are being eliminated, such as SOIC, PLCC, or even TSSOP. I think in terms of profit margins, for a high volume classic lead frame assemblies, they are being pushed toward single digits beginning of the year 2000. As you know, that the specialty item that few semiconductor manufacturings were supporting. One single size PLCC or SOIC package can cost about 300,000 to 400,000 just for the trim and form toolings. And this is not flexible process. Different with QFN, wherein I explain the mold tooling dimensions and outside lead frame dimension are the same for many QFN, which use common mold tool or common source singulations. And in fact, QFN are, in terms of other aspect like throughput, they are much faster without trim and form operations. Another thing, they are requiring less physical space. Again, because of this is more on faster throughput. Then in terms of quality, higher yield spells compared to the classic lead frame assembly that require trim and form operations. Any add-on, Dan?
No, no, I think you answered it pretty well.
Yeah.
All right, so the next question we have here is a multi-parter. As sustainability becomes a bigger topic, are you seeing a wider range of companies designing products that are easier to repair? And to what extent is that changing the profile of what a long life cycle system is? How are you adjusting to that?
I'll take this one, Edward. You know, from the semiconductor companies aren't doing that. So just to be clear, they're not doing anything to enable repair and refurbish. That's not them because they're not kicking out a final product. What we're talking about is our end customers, and our long-term system customers are now they are doing a better job than they were, say, 5 years ago or even 10 years ago about designing for long-term. We think there's things they can do that improve that even better. And that's part of our BOM health analysis and our system analysis that we can do. But in general, they because they've been hit with obsolescence so much, they are designing for change a little bit better than they were 5 or 10 years ago. I would say you go back 10, 20 years ago, no way. They were not really designing for obsolescence as much as they are now. So I think it is changing the profile of the long life cycle system a bit, but and for us, it really doesn't change what we do. Again, we're trying to enable them from a component perspective to keep their software from changing for the most part. Software kills the system, a long-term system. That if it has to be touched or changed, that pretty much kills the system because they can't. There's the order of magnitude cost difference between a component change versus a software change easily, and we're talking in the millions of dollars. So I think we see generally long-term system companies becoming more aware, doing things differently. They've been hit with so many obsolescences and supply chain notices here, especially 2 years ago, where the boom just absolutely pushed lead times out 52 weeks, 60 weeks on some products that they had to become more aware. So I'd say that it isn't the classic refurbish type of thing like consumer devices you hear about, whether your iPhone can be fixed or repaired or whatever. It's not like that, but the intelligence by our long-term system companies is definitely elevated now, and they are starting to put in a lot more hooks for what if this goes away or that goes away. So hopefully that answered your question.
All right, so the next question we have here is, what do you see as the next package assembly types to become obsolete after PLCC?
Go ahead, Edward.
Okay, let me take that. Yeah, as I explained in my previous slides, some of the SOPs or the small outline packages, such as SOIC, MSOP types, or second one is the QFP. These are the LQ, TQ, MQ, and then we have some TSSOP. These are based on our voice of the customers, which we have engaged since 2 years ago. So we are building right now the capability in-house so that we can continue the supply chain and avoid the disruptions. Thank you for the question.
All right, so we have another question that came in. It asks, what vulnerabilities are there with managing an OSAT supply chain to continue to source products if it's still active today?
I'll take that one, Edward. You know, you take a look at what is an OSAT supply chain. So let's talk about the different aspects of that. I brought this up briefly earlier, but let's walk through what they are. It's really three places in general. It is semiconductor fabrication, that's the wafers themselves, then it's assembly, and then it's test. If you manage the OSAT supply chain, you aren't driving the volume at the semiconductor fab. So you do not get to decide when that semiconductor fab process goes away. So if you're managing an OSAT supply chain, you rely on that semiconductor wafer technology to still be available. So that's one point of obsolescence that you're not managing, unless you're going to do wafer sort, in which case we've got a whole thing on challenges with that, which can work, but it has some additional challenges. Second part is assembly, and we talked at length about that today. Assembly is whether or not your lead frames are still going to be available. Does your trim and form tooling need to be refreshed? In other words, another $300,000 or $400,000 investment. Does that make sense? And now you're waiting for your assembly partner to perhaps run at a low enough volume that they don't want that type of assembly to be around anymore. They don't want to reinvest, because trim and form tooling doesn't last forever. It has to be replaced, has to be replenished. And that's a new investment for a volume that's gone down considerably. So that's the risk at the assembly side. And the risk at the test platform side is just that the test platform goes off of maintenance, goes out of scope from what the test house wants to continue to do. If you look at every major test place out there, they try to have a homogeneous test floor as much as possible, as many of the same kind of tester platforms as possible. That's how you get economies of scale. That's how you get your knowledge base all up. That's how you get your maintenance down to a level that you can afford, because the profit isn't that great testing product. And so the moment that test platform starts to look like it's going away, off support, becoming a minor platform in your scheme, you're going to obsolete because of the test platform. You're going to say, I don't want to move this. I don't want to port this. So if you're managing an OSAT supply chain, you are having to manage those risks now that all multiply on top of each other for whether the overall product goes away. That's why we have our own test floor. That's why we have our own assembly. And that's why we have more die wafer under storage than anybody else in the world. And so the reasons why we do all of this related to that is not just managing an OSAT supply chain. So hopefully that answered the question. All done?
All right, so the next question we have is, what are some areas of focus for Rochester's process and technology R&D in the next 1 to 2 years?
I'll take that, Dan.
Go ahead. Yeah.
Yeah, looking into our packaging technology roadmap, Rochester will be focusing on advanced packaging solutions. Just what I mentioned earlier, the product family of BGAs and QFNs. We will be increasing more derivatives for QFNs, like those 5x5 and above, or for DFN, we will go from 2x2 to 3x3. Okay. Another thing is the flip chip. We are developing the flip chip capability, flip chip for BGA as well as flip chip for QFN. And the third is the power products. As we all know, some of the power products are becoming obsolete also after 20 to 30 years from OSAT or OCM. This is mainly driven by the automotive and military market segments, which are coming from a product known as transistor outlines or the DPAC and SOTs. And for hermetic packages, we are focusing right now on hybrid modules packaging type. This being driven by our end customers in automotive also and aerospace. For test, I think I mentioned earlier the focus mainly on the next succeeding years is more on the flexible test solutions. Just to give an example, the tri-temp testing, the auto vapor mapping on vapor sort, as well as the auto test debugging systems. Hope I can. Dan, any add-on for the design
No.
technology?
I think that's good, Edward. I think you summarized it really well. I think again, we look for that input from customers and semiconductor companies directly as to where they want us to be, and we'll take that direction to heart and see what we can do to help.
Right.
Back to you, James.
All right, thank you both. Since that seems to be the last question, that concludes today's presentation. On behalf of Electronic Design, I'd like to thank our speakers for their discussion today, Rochester Electronics for sponsoring today's webinar, and of course, all of you for joining. Have a great rest of the day.
Thank you.